Hello. So I'm giving a presentation on Bitcoin. So what is Bitcoin? Bitcoin is a digital currency. So this digital currency uses a peer-to-peer Bitcoin network. It does not have any central authority, a central bank, or an administrator like a conventional uh, currency, because that is one of its most appealing features, because you do not have to trust any central authority or a bank, and all transactions in Bitcoin are recorded in a ledger called a blockchain. So what is the history of Bitcoin? So the domain name of bitcoin.org was registered in 2008. Later in the same year, a link to a paper authored by Satoshi Nakamoto was posted to a cryptography mailing list titled Bitcoin, a peer-to-peer electronic cash system. On 3rd of January 2009, the Bitcoin network came into existence with Satoshi Nakamoto mining the Genesis block of Bitcoin, which had a reward of 50 Bitcoins. On 9th of January 2009, the first open source Bitcoin client was released and hosted at SourceForge. The first retail transaction involving physical goods was paid on 22nd of May 2010 by exchanging 10,000 Bitcoins for 2 pieces. By 2011, other cryptocurrencies began to emerge, and these were based on Bitcoin's open source code. In 2012, the Bitcoin Foundation was founded. So, what is this blockchain? Blockchain is basically a way of storing information, and this is done using a chain of blocks. Every block contains a hash of the previous block leading up back to the Genesis block. Any contract between two parties can be established on a blockchain if both parties agree, and therefore there is no need for any third party intermediary in these transactions. These blocks of transactions are distributed, which means anybody can access them. At an average of every 10 minutes, a new block gets added to the chain and broadcasted across the network. And all of these blocks contain transactions in a chronological order. And this way, uh, any double spending or which is can be prevented. So what double spending is when you if you use the same amount, the same uh, the same Bitcoin for multiple transactions, which is obviously not allowed. And it has always been a very challenging question in the implementation of digital currencies. So and this is the way Bitcoin solves this. So and Bitcoin also requires you to refer back to your uh, uh, unspent output, which uh, uh, which is which avoids this double spending. So in all these transactions, you have to mention the address to which you're sending this, as well as the amount, and you can add an optional transaction fees which goes to miners, which incentivizes them to verify your transaction. We'll discuss miners shortly. Yeah, right now. So what mining is very important for Bitcoin, and uh, it is uh, one of the core components of the blockchain, and it actually builds the blockchain, and by discovering new blocks and joining them to previous ones. Miners spend their computing resources to create new blocks of transactions, and these transactions are and then these transactions, once they're in this block, they can be added to the blockchain. So the way this process works is that once you have collected these transactions and made a block, you have to add a, uh, add a number which, when hashed together with that block, gives a numerical value which is less than a particular set value called the network's difficulty target. This requires intensive computation, and whichever miner manages to first uh, get this such a number and gets to add this to the block. Since they're spending their computational power and resources on this, the network rewards them by uh, creating new bitcoins in the network and adding those to, and gifting those to the miner, as well as the transaction fees which they get from all those transactions within the block. So the hashing algorithm which is used uh, in this whole process is SHA-256. This algorithm secures these transactions, and since and so this is what is basically happening. All these miners all over the world, they're running hundreds of thousands of computers and generating many hashes, several hashes, and once a miner is able to generate a valid hash, that block gets added to the entire Bitcoin network, and this is basically what is called the proof of work mechanism. This proof of work mechanism keeps the network secure, and because of this, anybody that wants to create a fraudulent transaction which will have to you know to add that to the network, they will have to uh, do the majority of the work of the whole network, which means they will have to generate all those numbers and then uh, add those blocks to the blockchain so that their version of the ledger gets accepted by the network. The network always uses the longest possible uh, chain, which because that is the chain which has the most computational work attached to it. So if you want to, if a fraudster is trying to make their own version of the ledger and make that the Bitcoin network's ledger, they will, at the same time, they are competing with all these hundreds of thousands of miners who are working with the actual version of the with the non-fraudulent version of the ledger, and he will have to outwork them, and only that way they will be able to add that to the network, which is practically impossible to do, especially as the network keeps growing larger and larger. Obviously, one of the biggest features of Bitcoin is that there will be a limited number of Bitcoins. The only way of creating new coins and adding them to the network is mining and the reward that comes with mining. So after every 210,000 uh, new blocks, uh, the Bitcoin reward that is awarded for adding a block gets halved. So eventually, just under 21 million Bitcoins will ever be created into existence. And the last mine Bitcoin will probably be mined somewhere around 2130 or 2140. The difficulty target, which I mentioned, is also variable. So which adds to and they try to keep the average duration between block creation 10 minutes so that blocks get created quickly, and anybody that is trying to um, create a fraudulent ledger will have a hard time keeping up with the block creation. So anybody, if you purchase Bitcoin and you're doing transactions with Bitcoin, you probably have a wallet which has which holds basically your public key and private key, because any transaction within this Bitcoin blocks will have to be digitally signed. And to create your own digital signature, you will need your private key, which is confidential for you, and your public key will be visible to anybody, and they can use that to verify that it is you that has signed the document. So that is basically the crux of Bitcoin. This proof of work mechanism can often come into criticism because since it basically depends on computational power, and that can there are concerns that can harm the environment.